You guys will be pleasantly surprised at the ease at which solving equations with radicals in it are. It is one of those things that you guys have been doing for a very, very long time, solving for x. You know how to work backwards in an equation. Absolutely nothing changes here except some of your last steps and taking instead of square rooting, you might be taking the 5 or the 2/5 power of something. For example, if I just have something very basic as, I don't know, 2x squared minus 1 is 7. I had to think of something that would work. What do you do first?
Add 1.
You'd add 1. Then what?
Divide by 2.
And I took a square root over an equal sign, I'd get x equals plus or minus 2. You've done that problem for a long, long time. Right? Yeah. Okay. You want your homework?
Yeah.
We don't do this.
Stinky, like what? What?
Wait, is that actually all of it? Wait, Mr. Murphy, is this all this section is?
Kind of. Here's what happens.
I bet you it's man. I bet you that's what it's been.
Let me go to something like this.
Okay.
We have the cube root of x subtract 4 equals 0. You're going to do the same thing. You're going to try and isolate x. Get x by itself.
Add 4.
Very good. Add 4 to both sides. We have the cube root of x is 4. How do you undo cubing, or cube rooting?
Cube it.
You cube it.
Cube it shut.
You get 64.
That is ridiculously easy.
What? Stop.
Could you check your answers to make sure you're correct?
Yes.
It would be a wise idea because you may or may not wind up with an extraneous solution. Yes, sir?
So if the exponent is odd, then it's not plus minus.
Correct. When you're taking roots like that. If you take fractional roots, you don't have to worry about it either.
What?
Okay? What's going to change? You still work the same direction. You still follow the same steps as you would before. You undo everything. You work backwards from your order box.
Like Black Ops?
So, what would I have to do first?
Divide by 2.
Divide by 2. I get x to the 3 halves is 125. Now, when you're dealing with fractional exponents, what you're doing is you have to undo them by raising them to their reciprocal power. Very good. Because if I raise it to the reciprocal power, I have power to power, which means you would multiply those together, and you get x to the 1. But I did 2/3 power on one side, which I have to go 2/3 on the other. Now, 125 to the 2/3, believe it or not, you can do in your head. It means, what's the cube root of 125?
5.
Square it.
25.
So, what's the 2/3 root of 125?
25.
Whoa.
Do you guys know how to press the button in your calculator to raise it to fractional exponents?
Yes.
Caret button.
Alpha Y.
Alpha y equals to create your fraction bar and press the button. There is a 1.
I like carrots.
Are you a rabbit?
I actually don't like carrots.
No, he thought you meant that there was just one button to press.
There is one button to press.
No.
The other one.
The other one.
Okay? Continue on. Excuse me. As you go on to these things, a lot of it doesn't change. You're still doing the same stuff as you walk yourselves through it. You still have to move things before you can get rid of the radical. What do you have to move first?
The 2.
The 2, very good. How do you undo square rooting? Square to both sides. Square root of junk squared is? Junk. Sweet. I must have deleted the page. Oh, there it went. Found it. And now what?
That's 7.
And then?
What?
You kind of looked at me like in a bit of daze.
No, my head just hurts.
Want me to step on your foot?
Yeah, go ahead.
Because then your foot would hurt.
I get it.
I just.
You'd find that a lot. Okay? So, the next step in making it a little bit more difficult. No. So in this case here, as soon as you wind up with problems where you have multiple roots, your best bet is to get one root on each side if you can. That way you can square to get rid of them. Okay? One or two degrees. So I'm going to add the 2 root x to the other side. And you're right. At this point, I want to get rid of the radical, which means I have to square both sides. Here's the mistake that you're going to make. You're not going to square the 2. There you go. When you square something, you're multiplying it by itself. This side is no big deal. Square root junk squared is just junk. The other side, when I go 2 root x times 2 root x, I'm going to get 4x. Now check it. Will that work? Well, what's 3 times 2?
6.
What's 6 plus 2?
8.
What's the square root of 8?
2.
What's 2 root 2 minus 2 root 2?
0.
Hey! What's up? Square rooting. If we're square rooting to get rid of undo an x, just undo a singular x value, that's what we worry about. When you square it, it doesn't matter. Yes, sir? That is the question. Yeah, here I have to undo this, I square it, so here I have to square the 2 and the x. Because there's.
I thought I heard you say not.
Oh,
That's what I thought. That's what
I'm sorry, no, because think about this, guys. This is the same thing as saying distribute power of 2 squared, and then it's. So that's how it works.
No, but like when I said that, you're like, you were not. I was like, oh.
Sorry, I must not have heard you. I've been saying that every once in a while you could come across an extraneous solution, so I might as well give you an example that will tell you that you have an extraneous solution.
Yep.
So that way you can see what exactly happens. You get the answer, that's not an answer. So if x minus 4 equals the square root of 2x, what do you do first? Square it.
Square it. That's what I said. Then you plus.
Oh, goodness. Oh, goodness.
Ladies and gentlemen, please, please, for the love of the puppies, don't kill a puppy here. Write it out. You get x squared minus 8x plus 16 equals 2x. I just said don't kill a puppy! Pull your hair over your ears so you can hear better.
Pull them up on your hair? You said pull them over.
Exactly! Pull it over your ears.
Oh, that way? I thought you meant like, all good. Let's pull
You
them
don't
behind-
have that issue.
That's pull them behind your ear, not over.
You almost did.
Over would be this way.
brother
Like
does.
behind your ear.
Have you seen
I've had hair for a year. I don't know what this is like.
Are you ever gonna go home?
Sorry, that was
And now you have to solve it. What times what 16 you add together to get negative 10? Negative 2, negative 8. Good. What are your possible zeros in this case? 2 and 8. It might not work now. So check it. What's 2 minus 4?
negative?
Negative 2. Am I going to get a square root that's going to give me a negative? No. That one won't work. What's 8 minus 4? It's 4. What's the square root of 16? 4. Now the reason that it's not plus minus because you didn't take the square root over an equal sign. Here you're just saying, does 2 minus 4 equal the square root of 2 times 2? The square root of 4 is 2, but it's not negative 2.
But negative 2 times negative 2 is still 4.
Correct. But when you do plus minus stuff is when you take a square root over an equal sign.
So
Not when
square
it's
root always, unless it has plus minus, is always implied that it's positive.
Correct. Unless you're taking that as take the square root of something over an equal sign under the square root. Okay, that's the only thing to worry about. Yes, ma'am.
Two is still solutions, just an extra.
Correct. It's the answer, but it's not the answer. Okay? Do this one.
Don't tell me how to live my life.
What?
Don't tell me how to live my life.
I'm sorry. As your life coach,
Okay.
Oh, man, you gotta give me my calculator.
All right.
you don't need a calculator for this.
Yeah, X.
So you start out with doing what first?
Moving the one up there. Or adding.
Moving and adding. Yeah, that's fine. I understand what you're going for. Add the 1 over, you get x plus 9 to the 5 halves is 32. How do you undo a 5 halves? 2 fifths. Good. So you get x plus 9 is 32 to the 2 fifths. Remember, 2 fifths power means what's the 5th root of 32 squared? 4. Which one's what?
Which one is 5?
Yeah. The nth root is always the denominator. You get negative 5. So you check that. What's negative 5 plus 9? 4. So 4 to the 5 halves means what's the square root of 4? 2. What's 2 to the 5th power?
32.
What's 32 minus 1?
31.
That's so cool.
That's cool.
Yay!
This can be. Yes, sir.
How did you, the fifth root thing, how did you know that? Like, oh, so that's not something we should know?
The fifth root of 32?
What?
You should know that.
How?
What are 5 numbers that are small enough that you multiply together to get 32?
Two.
Oh.
Well, some decimal.
Times two.
Not 5 times.
Think of it this way. When you're doing things as far as exponents, obviously exponential growth is quick. All right?
You have like one.
If you have 2 squared is 4, 3 squared is 9, 4 squared is 16. It grows exponentially as x gets larger. But if you just change the exponent off a low base, 2 squared, 4, 2 cubed, 8. You're just multiplying each one of those successively by 2. 2, 4, 8, 16, 32, 64, 128, and so on. You're just doubling it. Doubling is, you can do that before you get too large. When you go by 3s, if you go 3 squared, you get 9. 3 to the third, so you times that by 3 again, it's 27 times 3 is 81. 243, you're getting bigger, quicker, and quicker.
Yeah.
Because the base was larger to start with.
So
You see something like 32 when you have a fifth root, it's going to be 2.
All right.
Small numbers, especially if they're even and you have roots to it, probably 2. But you have a button.
I'll check it. But I mean, I was just curious because you were like, that's obvious. I was like, oh, I didn't know that. Crap.
Well, I mean, like, because.
Do you go like each square the answer, or do you square like let's say that is square first and then teach the next root of it?
Take the fifth root first and then square it. It's always easier to go that route. Because when you rewrite it, if you're doing that as 32 to the 2/5, it's the same thing as saying the fifth root of 32 squared. Because you're breaking it into the fraction and then pulling that part out. It's just cleaner. What's the other one I want to do?
You didn't even finish that.
Oh, we did? Oh, I thought we did that one.
No, we didn't.
Sorry. All right. What do you do first?
Minus 5.
Okay. That's going to the 5th power. I don't know. Now, if it makes you feel any better, I have no freaking clue what 4 to the 5th power is.
1,000.
So if it makes you feel any better, I don't know what 4 to the 5th power is. I know what 4 to the 4th is. 256. Because it's 4 squared squared.
4 to the 5th power is 1,000.
I just like, now I'm thinking about the 32 thing. 32's smallest, like, square, right, smallest perfect square. That's right, perfect square would be 4. So, I mean, that kind of makes sense. So, if it was a number like not 32,
And it's okay that you get a fraction for an answer. Yes, sir.
so this is a long time ago.
You can leave it like that. A mixed number.
Yeah, you stop.
All right. We'll use a mixed number for like a minute or two when we do this stuff in the second semester.
Stop.
Actually, a minute or two? Or like.
Oh, no.
I didn't take off just one problem.
Oh, jeez. That is. It's a Christmas miracle.
So take a second before you start to criticize Shinty.
I wasn't criticizing.
Whatever.
I was saying you took off for what?
You think I'm going to
Oh, you just take off one. That makes it up for the workload decreasing jerks. Thanks, Sam. So I have that. The reason that I decided to basically cut it in half is that I want to spend a couple minutes here real quick reviewing the first few sections of 7, and I lost count, so I'm just going to do this. And I want to spend a couple of minutes going over a few problems off of this sheet here, especially as they pertain to working with the weird fractional exponent stuff.
You're right.
Try this again. Thanks, sir. So I want to look at the first four. The other parts of these are pretty straightforward. The first four are the ones that it's been a while since we've seen. Okay? Now, what I want to remind you guys is the shortcuts of how we were able to simplify radicals of nth roots. Do you remember how to use your calculator to find the perfect cube root that's in 192?
Yeah.
You're shaking your head. Remember how do you find the perfect square root? Well, take your calculator out. Go to your y equals. And I want to put in 192 divided by x cubed. That's the shortcut to allow you to figure out where your perfect cube root would be. I know we talked about this briefly when we did square roots. Remember how we did like the square root of 8, we put it in the table and we found out, oh, it's 2 and a 2, so it's 2 root 2. It's the same thing. It works for any nth root. If you had to do the 4th root, 5th root, 8th root, whatever. You take whatever you're trying to find the root of and divide it by that to whatever nth power. So as I'm going through my table then, I'm just scrolling along. I see, oh, I've got a 2 root 24, but then I have a 4 root 3. So that means the cube root of 192 would simplify to be 4 cube root 3. Okay? That's what that means.
Would that be the same thing as multiplying by a third, but you get it radical form? Or is that too?
Yeah, leave it in the radical form. It's quicker. It's easier to do. Yeah, you can do it x times x to the third, but it's cleaner in the calculator to do this one. So you get 9 times 4. Now we have this cube root here, and we know that there's a 3 inside. I took the 4 out, left the 3 in. Remember the shortcut for figuring out the exponents now? Yeah, exactly. How many times does 3 go into 3?
1.
So 1 comes out. Is there any left to stay in?
No.
How many times does 3 go into 10?
3.
How many come out?
2, 3.
3 goes into 10 how many times?
3.
How many come out?
1.
No,
3.
3.
1. 3.
3, but 1 stays in.
3. 1 stays. 2 stays.
You. You go like this. Yes. And you do this one. Thank you. So,
Y'all monkey boys.
See, now that's in the lesson plan.
I win! So 3 goes into 10 3 times. How many are left over?
1.
3 come out, how many stay in?
1.
Oh, yeah. No.
Nope. 3 goes into 6 how many times? 2 of them. Is there any left over? So the only thing I have left to simplify is 9 times 4.
Is it 12?
Wait, was this the first thing you did?
Okay. When it goes to the fractional exponents, start thinking about, okay, 49x squared to the 3 halves is, what's the square root of 49x squared? Cubed. So you get 7x. So it's 49 times 7, it's going to end in a 3.
Oh.
Okay? Now what's nice about this is that I'm not taking the calculator away from you tomorrow, so you can type in 49 to the 3 halves. Okay, great. But the weird part, the more difficult part, that even a calculator probably will remind you of a lot of, is how to do this. Here, you have all of your rules of exponents all put together. You've got your power to powers, when you multiply. You got the same bases, different exponents. When you're multiplying, you have to add. You have negative exponents, you have positive exponents, you have things flipping from side to side. And if you read the instructions, it says no fractional exponents within the denominator. So we're going to have to rationalize.
Nice.
When you have fractional ones, it actually is pretty easy to do with the rationalization because you're just trying to add up to the next whole number. Okay? So my suggestion when I do stuff like this is I'm not going to move anything until everything's all distributed and done. So distribute out, you got your power to power. A to the negative 1 to the negative 1/3 becomes a to what? A to the 1/3. Okay? B to the 4/3 to the negative third is b to the negative 4/9. I do the same thing in the next set. I have a to the negative 3/2 to the negative 3/4, and I get a to the positive 9/8. Okay with that? 3/2 times negative 3/4 is negative 9/8. And it's still all over A. Now, does everybody see that you have a 9/8 and an A and a whole A below it? Who wins in that battle of war real quick? The 9/8. So what would the 9/8 simplify to be? 1/8. I'm going to get rid of this guy right away because I noticed that I can do this and get 1/8. 9/8 over 8/8 basically becomes 1/8 in the top. Yeah.
If you had done that with the 1/3,
And then it would drop down to the bottom, but then you'd have to rationalize it and bring it back up anyway. So I'm just putting things all together at first and then see what happens. So far, so good? Now, I have two exponents that aren't happy with the b's. So I'm going to rewrite this. I have a to the 3rd, a to the 8th, over b to the 4/9 and b 9/8. Now's where the calculator comes in handy. Same base being multiplied, which means you just add your exponents. So I have to figure out what is 1/3 plus 1/8, and I have to figure out what 4/9 plus 9/8 is. It's going to be 24, so it's going to be 8 over 24 and 3 over 24, so it's 11 over 24. And then the bottom, we get 72, so it'd be 36 and 81. 113? No, 36 and 81 is 117, excuse me. You guys have a calculator. I'm trying to use my brain. It's not that good. 113, thank you. So it's b to the 113 over 72, because I just put them together. Now you have to rationalize. This is where it gets interesting. You want to get rid of the fraction. So what you want to do is you want to create the next whole number. So let me ask you, is 113 over 72 bigger than 1?
Yes.
Is it bigger than 2? No, it's not, because if I double 72, what do you get?
144.
So I need to make this fraction on the bottom b to the 144 over 72, which would make it b squared. I want it to be there.
Aha!
Within my bases, all I have to do is add exponents. So what do you have to add to 113 to make it 144?
131.
Or not
31.
You know what I meant.
Because this is a factor of
1.
1.
Oh, I was so confused. Wow.
So your final answer would be A 11/24, B 31/72.
But then don't you have to simplify and subtract out the front?
No, because if you do that, you're going to get an infinite loop.
Yeah.
That's
okay.
why this instruction says make sure no fractional exponents in the denominator.
Okay.
By doing this, you have no fractional exponent in the denominator. You rationalize it, and you're good
Okay,
to
so
go.
you just don't simplify that.
Aren't you adding in the numerator?
They're two different bases.
I know, but like, did you put, so we should put plus music, right? 'Cause I don't
No,
know.
it's multiplying.
Oh, it's multiplying?
Yeah.
Oh, it's
So usually you multiply
that's
that.
fine.
Now, let me, I don't want to say dumb it down, but let me show you.
You can say double that.
All right, let me dumb it down from a nasty fraction. I wanted to show you something that would be awful, but really all you need to do is just come up with the next whole number. What if you had this? Let's say you had x squared over y to the 13/5. What's the next whole number as far as the fraction would have to be? I'd have to get it to 15, but you're right, Shimki. I'd have to get it to 15 over 5.
2/5.
So what do you add to it? 2/5.
Multiply.
Right, because you're adding your exponents when you multiply by the same basis.
Gnarly, bro.
That's where you get y cubed. It didn't change when it just looked like, oh no, it's 113 over 72. It still get to the next whole number. Okay? It's just a nastier looking fraction.
Okay.
You're a nastier looking fraction.
Wow.
I'm just kidding, I'm sorry.
I like how slow she said that.
Okay? So let's look at the second one real quick. Well, we have like a minute left.
I like it better when we do the hard version first and then you go back and do it. I like it.
Good. Same deal. I'm not going to move anything around until I distribute the exponent that's in the denominator. And then I'll worry about moving stuff. Power to power, I have to multiply to both of them. So let's see, 14 over 12, 7 over 6. Yeah. So it's x to the negative 7/6. And then y to the negative 35/16. Okay.
Or outside.
I've distributed the power to power part. At this point, I'm going to make everybody happy and move stuff around.
Wait, time out. In the y, can you not simplify the y's on the top?
What's that?
Can you not simplify y to
I wanted to get rid of this part first before I do any of the other stuff.
Okay.
Because now I'm going to move everything where it has to go, and then I'll simplify.
Okay.
Try not to do too much at once. I want positive exponents prior to simplifying. You'll be less likely to mess up. Okay. So move stuff that needs to be moved. 2 y's come down. Y big. It's a whole hodgepodge of junk. So we get x 7/4, x 7/6, y 35/16, y 5/4, y 5/3.
Why?
Alright. And now worry about your simplifying. You have 7/4 and 7/6. Count down to be what? 12, so it'd be 21 and 14, so 35/12.
What is what?
Please double check that. I think it's right.
This kind of check.
No.
Yeah, you're right. You're right. Wait.
Yes, I'm joking. Thank you. All right, now I have 5/4, 5/3. Count would be 12 again, so it would be 15 and 20, so it's 35/12 in the denominator. Like I said, it's 25/12 in the denominator.
Oh.
Wait.
Yeah, wait. Wait a minute, hold on. Yeah, where did the 35 times come from?
Yeah, 5 times 5 is 5.
Why do you have this 35? Oh, I'm so confused.
So which one? This one?
No, the X.
Oh.
5 times 5.
Yeah, that's 35. We're adding.
Is this 35 supposed to be denominator? I thought it was.
5 times 5.
No, I think you said 35, but you wrote 25.
Oh.
Because I wrote 35.
Okay.
That's what you said.
So now I have to figure out who wins. Because you get 15 twelfths for the one side,
Yeah.
20 twelfths for the other side. You gotta multiply, this one's gotta be multiplied by 3, this one's gotta be multiplied by 4. Yeah, you don't multiply across, you gotta get the commons.
You guys left me back last year.
What's,
When you multiply, does it not matter?
we are at, well, that's what we're doing, we're adding them. We're adding together to do that. Okay. So, play war, who wins, 35 16ths or 35 12ths?
35, 12.
12.
I don't know.
5 12.
The one
I
with the
think
smaller
it's
denominator.
So, figure out, what does that simplify to be then? We got
35 over 48.
What is it?
35 over 38 on the, or 48 on the
Okay.
How'd you get the X? Well, you'd actually finish it and then go back because.
I just added these two together.
Okay, I guess.
So it's x to the 35th 12ths over y to the, what would you say?
35, 48.
What do you have to add to 35 to make it up to the whole?
This makes me hungry. Oh my god.
Oh, is this what I heard?
Google fractional excellence simplification. I think it might be your best bet. Can't think of
I'd
it.
rather lose out here than chance to go way higher.
Yeah.
When I get home, I gotta sign on YouTube at lunch.
Yeah. That's what I have to say.
I heard that.